Chapter 6: Adding to the body's electrical system, high energy transfer techniques. The authorities of the London Cancer Hospital will be unfaithful to their honorable trust should they decline to test the fullest extent of the curative effects of frictional electricity in some of the most hopeless variety of diseases to which humanity is exposed. A. Allison, M.D., Lancet, 10 January 1880. A few years following the Galvani-Volta controversy in the 1790s, Galvani's father, rather odd nephew, Aldini, treated a man for a psychiatric condition by using multiple applications of direct current to the patient's head. This is the first recorded example of electrotherapy with a possible effective dose of electricity. Aldini claimed that the treatment was successful and that the patient was able to return to his normal activities. Given the state of the art at the time, the voltage and current used must have been small. Aldini could hardly qualify as an unbiased investigator because he had also been involved with such activities as reviving the dead through application of DC current to fresh corpses in sufficient amounts to stimulate muscular movement. At that time, electricity entered what could be called a therapeutic vacuum. The treatments available to physicians were mainly ineffective and were often toxic, with the recoveries due only to the resiliency of the human body. Electricity at that time was a mysterious, little understood force that was identified as the vital spirit of life itself. Obviously, it could therefore be considered capable of curing any ill. In 1812, a surgeon by the name of Birch, working at St. Thomas's Hospital in London, reported that he had successfully treated a patient with a non-union of a fracture of the tibia by using shocks of the electrical fluid. By 1841, his bone growth stimulating technique had progressed sufficiently to be considered the treatment of choice for such conditions. Other diseases states were not neglected during this period. In 1860, Dr. Arthur Garrett, a fellow of Massachusetts Medical Society, published a book entitled Electrophysiology and Electrotherapeutics, with instructions for treating a range of clinical conditions using electricity. By the 1880s, many medical schools in both the United States and England had professors of electrotherapeutics on their faculties. In less than 100 years, electrotherapy had become a respectable part of the average physician's armamentarium. While the techniques was not universally accepted by the medical profession, it offered a greater margin of safety than orthodox methods then in use. For example, bloodletting, leaching, and purging. Despite the fact that the technology was crude, one had to make one's own battery and instruments for administering and measuring the currents. Clinical reports was respected by physicians indicated useful effects, particularly in growth control and psychiatric conditions. However, by the late 1800s, the field had become infested with quacks and charlatans. By 1900, it was almost totally dominated by this type of entrepreneur. A wide variety of fascinating devices was promoted, including electrical, electrostatic, and electromagnetic devices, and simple permanent magnets. These had an alleged ability to cure everything from baldness to flat feet. None of the claims was any way substantiated, and this circumstance reflected badly upon few serious attempts to evaluate either the basic biological effects or authentic clinical results. During this time, vitalism was losing its scientific basis. Electricity was no longer viewed as the life force, but simply as a form of energy that had useful clinical effects on its own. It was thought of something akin to a drug, and if a little was good, more was considered to be better. Many respectable physicians devised therapeutic devices. They put forth elaborate theories which were unsupported by fact to explain these devices. The amounts of current, voltage, or field strength and frequency applied were based simply on the physician's intuition, and the placebo effect was ignored. As scientific medicine became more firmly established, most such devices were shown to be of little value and totally without scientific foundation. By the 1930s, some of them had disappeared entirely, although a surprising number persisted in use with a steady trickle of patients being treated by the physician inventors. At that time, the only scientifically valid use for electromagnetism in medicine was in the field of diagnosis, specifically through the use of electrocardiogram and the encephalogram, and of stimulator type devices for the testing of nerve and muscle injuries. Initially, the FDA felt no need to move against any diagnostic electrical device, and only the most overt therapeutic quacks were prosecuted under the agency's general rules of efficacy. By 1950, most of the fraudulent devices had been removed from the market. However, some of the devices promoted by legitimate physicians were left untouched on the premise that a physician may treat a patient in any way that he deems best. Until 1978, in fact, there were no specific rules governing medical devices, either therapeutic or diagnostic. Under the law enacted in that year, new devices of all types had been approved by the FDA, but any devices that had been in clinical use before that time were grandfathered, that is, they were granted immunity from the regulation. These older devices could continue to be manufactured and used regardless of their efficacy or potential side effects. In actuality, the FDA appeared to adopt the position that electrotherapy was harmless nonsense and, if left alone, would soon disappear in favor of proven efficacy therapies. This simply did not happen. As the scientific revolution began in the 1960s, reintroduced electricity back into biology. The use of these grandfathered devices expanded and new devices appeared. The rise of modern electrotherapy. Before we discuss treatments involving the administration of electrical current to patients, some basic aspects of this process must be understood. For any current to flow, a complete electrical circuit has to be established. This requires that two electrodes be used. Both may be on the body surface or inserted into the body, or one may be inserted and the other placed on the body surface. The current flows between two electrodes, generally along the shortest, most direct route. Current or voltage density, that is, the amount passing through a defined unit area, is greatest near the electrodes. Along the flow path between the electrodes, the current will spread out and the average current density will be less. In this flow of current, certain harmful positions events can occur. First of all, electricity passing through any substance may produce heat. The amount of heat generated depends on the resistance of the substance and the density of current flow. For human skin, the rule of thumb is that 1 milliampere per 1 square centimeter is just below the level at which cell damage due to heat is produced. Currents in excess of this way may not produce perceptible heating, but they may still damage cells. Second, if the electricity is administered via electrodes made of metal, the positive electrode will give off ions on the metal itself. In many cases, such as with stainless steel electrodes, these ions will be quite toxic to cells. The toxic effect is not limited to the cells in direct contact with the electrode, because the positively charged ions will be electrically repelled by the positive field of the electrode and driven some distance deeper into the body. Third, with any level of voltage, the water within the tissues will be subjected to electrolysis, a process in which the water molecules are broken apart. In biological tissues, this produces gases such as hydrogen that are extremely toxic to cells. The rate at which these gases are produced is proportional to the level of voltage. The higher the voltage, the greater the amount of gas. At low voltages, the circulation of blood and tissue fluids will carry the hydrogen gas away and neutralize it. However, as voltage is increased, a certain level will be reached at which gas production is greater than the ability of the circulation to carry it away. This higher voltage is called the electrolysis level, and it results in the rapid accumulation of hydrogen gas and the death of all cells at the site. In my laboratory, we measure the onset of electrolysis in animal tissues using stainless steel electrodes. We found it to occur at about 1.1 volts, a comparatively low level. It should be apparent that electrical currents administered to the body may have purely physical side effects of an undesirable nature. In addition, as indicated earlier in this book, extremely small electrical currents have a variety of major biological effects. Most people who employ or promote electrical currents for treatments are either unaware of these effects or choose to ignore them. The black box treatment, transcutaneous electrical nerve stimulation. TENS. Pain has been a puzzle to both clinicians and neurophysiologists for many years. While tracts of nerve fibers that transmit pain sensations had been identified in the spinal cord more than 100 years ago, the exact structures that initially detect the injury, the so-called pain receptors, remain a mystery. Clinically, pain is a subjective symptom that cannot be objectively measured. One had either to take the patient's word for it or to prove the existence of some pathology that would justify the pain. Chronic pain, in particular, was a real problem. If the physician could not identify its cause and correct it, relief would require a long period of drug therapy with all the attendant side effects. In 1965, the gate theory was proved as a technique for the relief of chronic pain. This attractive hypothesis proposed that pain signals from the periphery of the body to the brain could be blocked through the insertion of non-painful electrical impulses into the dorsal columns, spinal cord tracts that carry the pain sensation. It was theorized that the gateway from these tracts into the higher centers of consciousness could carry only so much informational traffic, and that strong non-painful signals could block painful impulses. 2 years later, Dr. C. Norman Shealy, a neurosurgeon, reported that inserting stimulating electrodes into the dorsal columns produced relief of chronic pain in some patients. While this appeared to substantiate the earlier theory, Shealy's technique involved major neurological surgery, and it did not always work. In an attempt to determine in advance of surgery which patients would respond well to the electrode implantation and electrical stimulation, Shealy and his colleague, D.M. Long, applied electrical stimulation through skin electrodes over or near the area of pain. They theorized that stimulation of sensory nerve fibers in this fashion would block the gate, in the same way that electrodes implanted in the signal cord did. Initially, if patients reported control of pain with this technique, Shealy would proceed with the surgery or electrode implantation later. It became evident that the simple electrode technique worked just as well as the surgically implanted electrodes, and the surgical procedure was discarded as unnecessary. Several companies were formed to exploit this technology, and new, more efficient devices were designed and marketed. This technique became known as transcutaneous electrical nerve stimulation, or TENS. Because it was in use prior to the 1978 law, it was a grandfathered therapy. The actual technique involved the use of two electrodes, which were attached to the skin over the painful area, and a black box, a small battery powered pulse generator. The first generation of devices designed in accordance with the gate theory used high frequency, low current density electrical impulses that neurophysiologists had determined were maximally stimulating to the sensory nerves. However, the gate theory was soon challenged by other researchers, and TENS units that used electrical pulses of low frequency and high currents and that did not stimulate the sensory nerves were found to be equally effective in relieving chronic pain. Another approach was to provide the patient with an adjustable black box. In this way, the patient should choose the pulse shape, width, and frequency that seemed to provide the most pain relief. It is now evident that a wide variety of waveforms, pulse shapes, frequencies, and current densities will give considerable pain relief. Therefore, our effect cannot be due simply to stimulation of the non-painful sensory nerves. The gate theory has thus been discarded. However, even though no mechanism of action can be proved for their use, TENS units often provide considerable relief of chronic non-responsive pain unit, and they have become an accepted item in the modern physician's armamentarium. I have studied a number of such devices and have found that each one will eventually produce skin irritation at the electrode sites. The side effect can be eliminated temporarily by switching to another type of unit, but eventually the same side effect will occur. While I have found that these devices often produce considerable pain relief, I do not believe that the potential side effects of high levels of pulsating current have been fully evaluated. I therefore stopped using the devices and do not recommend their use unless all other possible techniques have been tried. The TENS units have actually provided an umbrella covering many other devices that use pulsing electrical currents and skin electrodes. At this time, one can choose from a wide variety of devices, all referred to as TENS units, and all marketed for pain relief. However, the actual clinical applications of these devices have gone far beyond simple pain relief, using a loophole in the FDA regulations that permits a registered physician to use an approved device in any fashion for any clinical condition on an individual patient. Manufacturers and physicians have employed TENS units for a multitude of non-recommended applications. They have, for example, been used to treat migraine with the electrodes applied directly to the head. A similar application has been made to treat drug addiction and memory loss. They are also being used to increase the rate of healing wounds in both soft tissue and bone to treat bladder dysfunction, as well as serve as electrical stimulators in acupuncture treatment. Major use has been made of TENS unit in sports medicine, where it is claimed that they reduce edema, dissolve hematomas, and restore full function to injured parts. Military jet fighter pilots apply the electrodes in advance of getting into cramped cockpits for extended periods of time, claiming that doing so prevents backache. It is obvious that most of the above applications have little to do with chronic pain, and I believe that most have no present basis in either scientific theory or research. We have come full circle from widespread unregulated use of electrostimulation devices to the total discreditation of all electrical effects, and now back to a widespread acceptance of such devices for the treatment of a multitude of conditions. There are several unfortunate aspects to this development. First, the original theoretical foundation for their initial use, the gate theory, is no longer accepted, so the mechanism by which these devices reduce pain is unknown. Second, at present, there is no scientific basis for their use as non pain relieving applications. Third, there is no recognition of or search for any deleterious side effects. This latter aspect is particularly important. Each TENS unit exposes large volumes of patients' tissues to substantial electrical currents that are pulsing at frequencies not normally present in the Earth's electromagnetic field. As we shall see, such electrical forces do have important and often undesirable side effects. There are so many devices currently on the market masquerading as TENS units that it is impossible to review the characteristics, theoretical foundations, and proposed applications of each one. Suffice it to say that at this time, my recommendation would be that use of these devices be limited to chronic painful conditions that are unrelieved by standard treatments and their application limited to areas of the body other than the head, neck, and spinal cord. Each patient must be thoroughly evaluated in an attempt to determine the cause of the pain so that other treatment methods can be tried first.